Hello and welcome. In this video we're going to continue section 7.8 and look at example 2, which is the integral from negative infinity to infinity of dx over 1 plus x squared. Now remember from the last part we talked about how to handle an integral from negative infinity to infinity, and that was to split the integral up into two integrals, one from negative infinity to c, where c just represents any number, and then the other from c to infinity. That way we're covering everything. And then we would add up those two areas under those two intervals, under the curve of those two intervals. Alright, so that's what we're going to do right here. We're just going to pick a number in between, just any number, in between negative infinity to infinity, which is any number. And we'll just pick 0, for example. So we'll split this integral up into two integrals, one from negative infinity to 0, of dx over 1 plus x squared. And then we have plus the integral from 0 to infinity of dx over 1 plus x squared. Now the numbers that go on the top of the first integral and the bottom of the second integral have to be the same, because you're making a cut at that number and then evaluating the area under the curve on those two intervals and adding those two areas up. Well, for each of these we can replace the negative infinity or the infinity with a t and then let t approach that infinity. So for example, on the first integral, by definition of what that integral means, we would replace the negative infinity with a t, and then take the limit as t approaches negative infinity. So you can see this negative infinity on the integral was replaced with a t, and then we're taking the limit as t approaches negative infinity. Then do the same thing for the second integral. We'll have the limit as t approaches infinity of the integral from 0 to t of dx over 1 plus x squared. Now you can reuse the same t variable just because the scope of t only lasts as far as the end of what's inside the limit, right? And so when we put this plus right here, then the scope of t is ended, and so now we can use it again. Just like in programming, if you've ever done programming. Alright, so now we have to evaluate each of these integrals. So the first integral we can evaluate. So here we have the integral of 1 over 1 plus x squared, which, if you remember, is inverse tangent of x. So we have limit as t approaches negative infinity of inverse tangent of x from t to 0, and then plus the limit as t approaches infinity of inverse tan x from 0 to t. So now we can plug in those limits of integration. I know the word limit is all overloaded. Limits of integration mean like the ends of your interval, but also limit is like a limit that you take. Just have to tell by context. So we have the limit as t approaches negative infinity of inverse tangent of 0 minus inverse tangent of t, plus the limit as t approaches infinity of inverse tangent of t minus inverse tangent of 0. Now we can evaluate and also take the limits as we go. So inverse tangent of 0 is 0. That handles both of these inverse tangent of zeros. And then the inverse tangent of t is, well, t is approaching different things in each case, so we're going to have to take them separately. Remember that inverse tangent, what inverse tangent looks like, is something like this. Just drawing a little picture of inverse tangent. So inverse tangent of x or t, depending on what variable you're using, basically has two horizontal asymptotes, negative pi over 2 and pi over 2. And as you're going from left to right, it starts close to negative pi over 2, goes through 0, 0, and then gets close to pi over 2 as you keep moving to the right. So the limit as, if we're using t for a variable, the limit as t approaches negative infinity of inverse tangent of t. There, the inputs to inverse tangent will be going towards negative infinity, and so the outputs are going to negative pi over 2. So this is negative of negative pi over 2. There's an extra negative outside the inverse tangent. Then we have plus the limit as t approaches infinity of inverse tangent of t. Well, as the inputs to inverse tangent go to positive infinity, the outputs are going to pi over 2. So when you add these together, you get pi. And then you can eat it. Okay. And just to see what the picture looks like, figure 4 shows a picture of 1 over 1 plus x squared. It's kind of a neat looking one. It's not exactly the bell curve, which is a slightly different function, but it sure looks bell curve-ish. And it turns out that the area under this 1 over 1 plus x squared curve is pi. It's exactly pi if you have your interval going from negative infinity to infinity, which is pretty amazing. So even though our interval was infinite, our area under the curve was finite. Pretty cool stuff. Thanks for watching, and see you in the next part.